Hello, gentlemen. Mr. Novak here. Another instalment. Request from a student for question number 13 out of exercise 80. That's three-dimensional. With this one, clearly you need to do some reading, lots of reading, and I would suggest you actually read all of it. And basically, like one previous example, which had three unknowns, this one has two unknowns. We don't know what the D value is or the H. Okay. And of course, H is the height of the tower, and D is the distance from the base of the tower. And so we need two equations. As you can see, we're going to end up with two triangles, and that's where we'll get our two um, formulas or equations, and we'll use the substitution method to solve for simultaneous equations. So let's read first. A tower stands at point T on a flat ground. So let's draw a flat ground. Remember, this is also a classic example of draw, very key to much. So at a point, call it T, we have a tower, a nice tall tower. So we did that. From point X on the ground, the angle of elevation from a point X on the ground, the angle of elevation to the top of the tower is 54 degrees. So somewhere along this, because remember elevation is to look up, so we need to find a place, say about there, and when we look up, yeah, that looks about 54 degrees. And that was to the top of the tower. So there's divide A. So now you want to understand what the A and T stands for. AT. Okay, there's your A and T. So that was 54 degrees. So obviously angle of elevation always measured from the horizontal, 54 degrees. Do not measure it from there, that's the vertical. Next point is a point Y on the ground in the same straight line, so same straight line as xt, but 25 meters beyond x. And this time we only have to tilt our head 28 degrees. Oh, see, obviously Y must be somewhere around here. Because now when I look up, I don't have to look up as tilt my head as high. That's 28 degrees. So we've done part A, okay? And we've included all the information. And as you can see, we have three triangles. And that's why we're going to look at the first triangle. So as I said, this is about two simultaneous equations. That's because we don't, oh, that's right. We said that this was a length of D. This is a length of 25 meters. So I haven't quite finished part A. Putting some information. That's an extra 25 meters. And of course, there's the H. And this is the problem. We have two unknowns, H and D. But fortunately for us, we have two triangles. We have this triangle here, which includes the height of the tower. And we have a second one, and that's the important two unknowns. We need two triangles. This time it's the green one, which overlaps. As you can see, it's 25 plus D, and of course that uses the same height. So that's why it's simultaneous, because they both have the same H value. So using triangle, so that's triangle AXT. So there's AXT, triangle AXT. Let's draw that again. Triangle AXT, assuming that we're making an assumption here that the ground is flat and the tower's up straight. There's your T. Come on, T. There we are. There's the 54 degrees. And we don't want the height in terms of D. Well, that's what we said. We don't have any other information. So on we go with labeling. Always the hypotenuse hypotenuse first. I like to do the adjacent. It's always next to the, and that leaves 0. The two lengths that we are interested in is A and O, so that's 10 feet. So write out your ratio. TOA, make sure it's O over A. Common mistake is you get those the wrong way around. So we have 10, 54 degrees equals H on D. And remember, they just want H in terms of D. So we need to just simply multiply both sides by D. And so we end up with H equals D times 10, 54 degrees. So that's part B done. Now, as you can see, we're going to set up the next triangle, which is triangle AYT. So let's do that. Do that in here. So there's the Y. Ooh, there's the A, Y, and T. So let's draw that one again. So as you can see, we're going to be using the same ratio because here we have 28 degrees. There's the H, but remember this D is D plus 25 meters. So again, that's hypotenuse, that's the adjacent, and that's the opposite. So we're going to use 10 again, but this time H is use 10 theta equals O over A. So 10, 28 degrees equals H over D plus 25. We better put that in brackets. So we end up with H equals brackets D plus 25. Remember, we've got to do addition first before we do the multiplication, so we have to put it in brackets. So we get BODMAS to work for us. And so there's our two equations. Call that equation 1 and that equation 2. And now equate your two equations from part B to solve for A. In other words, we're going to use the substitution method. If this H here is equal to that, then we can replace that H there with that expression. So substituting 2 into 1, we get sub 2 into 1, end up with D plus 25. Remember, we have to put it in brackets. 10, 28 degrees equals D 10, 54 degrees. We might as well use our solve button on our calculator. Remember, we're solving for D, close the brackets. Let me just pause while I get my calculator. Okay, so it's menu 3.1, solve. We had brackets D plus 25, so plus 25, sorry, times it by 10, times it by 10, not twice, 10, brackets, checking that we are in degree mode, 28 equals D times 10, 54. We're trying to solve for D, and there we have D is 15.737 meters. All right, let's go to 15.73 meters. D equals 15.73 meters. All right, and so there's our distance. Okay, so we now have found what D is, and to get H, we'll just substitute into either one of those two equations. Obviously, we'll substitute sub D equals 15.73 into 1, equation 1. My pen's not working too well. And let's go to our calculator again. Don't worry, can't do this without a calculator, unless it was a well-known angle like 30, 60, or 45. So all we need to do is go D. So that's the answer. Oops, no, answer, sorry. I just want the answer. So that times it by tan 24, no, tan 54, sorry, tan 54 degrees and percentile, and we get 21.66. So if the answer is one decimal place, the answer will be 21.7 meter tall tower. So therefore, H equals D tan 54 degrees equals 15.73 times tan 54 equals 21.66, and we get 21.67 or 21.7 meters. So there's an example of another one, simultaneous equation, two unknowns, two equations, in this case two triangles. Have a good day.